Now let us get started with tangents and normals LAQ and take the first question. This question is very important. Recently appeared 4 times. Once in TS March 24, then AP March 24, AP March 23 and AP May 23. So the question is, if the tangent at any point on the curve x power 2 by 3 plus y power 2 by 3 is equal to a power 2 by 3 intersects the coordinate axis in A and B, then show that the length AB is a constant. So first let us write the given equation. What is the given equation of the curve? It is x power 2 by 3 plus y power 2 by 3 is equal to a power 2 by 3. Now we have to differentiate with respect to x on both sides. First tell me what is the derivative of x power n. X power n derivative is n into x power n minus 1. So here when you are differentiating the first term, in the place of n you have 2 by 3. So substitute n is equal to 2 by 3 in this formula. Okay. So we get 2 by 3 into x power 2 by 3 minus 1 plus 2 by 3 y power 2 by 3 minus 1 dy by dx is equal to derivative of a constant is 0. Now tell me what is 2 by 3 minus 1. So if you take LCM you get 2 minus 3 by 3. That is minus 1 by 3. So that is 2 by 3 x power minus 1 by 3 plus 2 by 3 y power minus 1 by 3 dy by dx is equal to 0. Now we have to find dy by dx. So take this first term to the right hand side. So you get 2 by 3 y power minus 1 by 3 dy by dx is equal to minus 2 by 3 x power minus 1 by 3. 2 by 3, 2 by 3 get cancelled. Take this y power minus 1 by 3 that side. So you get dy by dx is equal to minus x power minus 1 by 3 by y power minus 1 by 3. Okay, this is dy by dx. So we got dy by dx as minus x power minus 1 by 3 by y power minus 1 by 3. Now let us find out equation of tangent. What is equation of tangent at some point P? That is y minus y1 is equal to m into x minus x1. Now y minus y1 is equal to what is m? M is dy by dx. So that is minus x1 power minus 1 by 3 by y1 power 1 by 3 minus 1 by 3 into x minus x1. Here we are putting in dy by dx, we are putting x and y as x1 and y1. Now if you cross multiply, you will get y1 power minus 1 by 3 minus y1 into y1 power minus 1 by 3 is equal to multiply this into this into this. Minus x into x1 power minus 1 by 3 plus x1 into x1 power minus 1 by 3. Okay. So this is y1 y1 power minus 1 by 3. Here you have y1 power 1 and here you have y1 power minus 1 by 3. So you can add these powers because we know that a power m into a power n is a power m plus n. So minus y1 into 1 minus 1 by 3 is equal to minus x into x1 power minus 1 by 3 plus, here also bases are x1, you add the powers, x1 power 1 minus 1 by 3. So y1 power minus 1 by 3 minus y1, 3 minus 1 is 2. So 1 minus 1 by 3 is 2 by 3. This is 2 by 3 is equal to minus x1 power minus 1 by 3 plus x1 power 2 by 3. Okay. Now Now what do you get? Now we are taking this x1 power minus 1 by 3 this side and y1 power 2 by 3 that side. So what do you get? You get x1 power minus 1 by 3 plus y1 power minus 1 by 3 is equal to x1 power 2 by 3 plus y1 power 2 by 3. But in the question, if you see, what is x1 power 2 by 3 plus y1 power 2 by 3? That is a power 2 by 3. No, a power 1 by 3. Why? Since p x1 comma y1 lies on the curve, then x1 power 2 by 3 plus y1 power 2 by 3 is equal to a power 2 by 3. So this is 2 by 3 only. Yes, it is 2 by 3. So this is a power 2 by 3. Okay. So now we got this result as x1 power minus 1 by 3 plus y1 power minus 1 by 3 is equal to a power 2 by 3. Now we got this statement, okay? Now we will divide this by a power. This is a power 2 by 3, no? Yeah. So we will divide this by a power 2 by 3. So you will get x1 power minus 1 by 3 by a power 2 by 3 plus y1 power minus 1 by 3 by a power 2 by 3 is equal to 1 you will get. Now I will bring this x power minus 1 by 3 down and here y1 power minus 1 by 3 down. So it will become x by a power 2 by 3 by x1 power minus 1 by 3 plus y by a power 2 by 3 by y1 power minus 1 by 3 is equal to 1. Okay. Now we have converted this in intercept form, that is x by a plus y by b is equal to 1. Now this tangent meets the coordinate axis at a and b. Then x-intercept OA, this is x-intercept. See, this is x-intercept and this is y-intercept, okay? So what is OA? A power 2 by 3 by x1 power minus 1 by 3. And what is y-intercept? Y-intercept OB is a power 2 by 3 by y1 power minus 1 by 3. Now, AB square is equal to OA square plus OB square, no? So, we can write this as a power 2 by 3 by x1 power, wait a minute. So, that is a power 2 by 3 by x1 power minus 1 by 3 whole square plus a power 2 by 3 by y1 power minus 1 by 3 whole square. So if you add this, you will get a power 4 by 3 by x1 power minus 2 by 3 plus a power 4 by 3 by y1 power minus 2 by 3. If I bring the denominator up, what will you get? A power 4 by 3 into x1 power 2 by 3 plus a power 4 by 3 into y1 power 4 by 3. Now that is equal to, if I take a power 4 by 3 common, x1 power 2 by 3 plus y1 power 2 by 3. But from the question we know that x1 power 2 by 3 plus y1 power 2 by 3 is a power 2 by 3. Now we can add the powers. 4 by 3 plus 2 by 3, that is 6 by 3. 6 by 3 is nothing but 2. So a square is a constant. So we got ab square as a constant, no? That means ab is equal to a. That is also a constant. Therefore, the length AB is a constant. Now take the next question. This question is also very, very important. Appeared so many times. Recently appeared in PS March 25 paper and AP May 23 paper. So this year this question has appeared. So the question is, at any point t on the curve x equals to a into 1 plus sine t, y equals to a into 1 minus cos t, find the lengths of tangent, normal, subtangent and subnormal. So first let us write down what are the given equations. So what are given to us? X is equal to a into 1 plus sine t. One after the other we will take. Okay, first we will differentiate this equation. Differentiating with respect to t. See here, we are not differentiating with respect to x. We are differentiating with respect to t. So dx by dt we will get on the left hand side. A is a constant, we are writing aside, and derivative of 1 is 0 and sin t derivative is cos t. So this is a cos t. Now if you take y is equal to a into 1 minus cos t. Now if we differentiate with respect to t, we will get dy by dt is equal to a into derivative of 1 is 0 minus derivative of cos t is minus sin t. Minus into minus will become plus sin t. So that is equal to a sin t. Now how to find out dy by dx? We can divide dy by dt by dx by dt. So that is a sin t by a cos t. A cancel, sin t by cos t is tan t. So we got dy by dx as tan t. So there is a slight change in this question. Here you have t plus sin t. So if this is t plus sin t, then if you differentiate, we will get a into 1 plus cos t. Okay, so this is dx by dt. And now when you divide this, again there will be a change. A into you will get 1 plus cos t. Now sin t you can write it as 2 sin t by 2 cos t by 2 from trigonometry, multiple and submultiples. And 1 plus cos t is 2 cos square t by 2. So 2 cancel, 1 cos cancel. This is sin t by 2 by cos t by 2, that is tan t by 2. So you got dy by dx as tan t by 2. Now you see we got dy by dx as tan t by 2. Okay, so first we will find out slope of tangent. Slope of tangent at t is m is equal to dy by dx at a point P. So that is tan t by 2. Now what is length of the tangent? We need to find length of tangent, length of normal, length of subtangent and length of subnormal. So length of tangent formula is y1 into root over 1 plus m square by m. So what is y1? Y1 is a into 1 minus cos t and root over 1 plus what is m? Tan t by 2. So m square will be tan square t by 2 by what is m? M is tan t by 2. Okay. So that is a into 1 minus cos t. 1 plus tan square t by 2 is secant square t by 2. So this is root over secant square t by 2 by tan t by 2. Now square and root get cancelled. So you will get a into 1 minus cos t into secant t by 2 by tan t by 2. Okay, so secant, can I directly write it as 1 by cos? 1 by cos t by 2 by tan t by 2 is sin t by 2 by cos t by 2. Cos t by 2, cos t by 2 cancel. That is a into 1 minus cos t is 2 sin square t by 2. And what is sin t by 2? 2 sin t by 2 cos t by 2. 2 to cancel, sin cancel. So that is a tan t by 2. So over here in the denominator we have only sin t by 2. Okay. So one sin and one sin get cancelled. So answer is a sin t by 2. This is the answer for length of tangent. Now we need to find length of normal. Now we will find out length of normal. So what is the formula for length of normal? Length of normal is mod y1 into root 1 plus m square. So what is y1 from the question? It is a into 1 minus cos t root over 1 plus what is m square? Tan square t by 2. That is equal to mod a into 1 minus cos t formula is 2 sin square t by 2 and 1 plus tan square t by 2 is secant square t by 2 and root over secant square t by 2 is secant t by 2. So that is equal to mod 2a sin square t by 2 secant t by 2 we can write 1 by cos t by 2. Okay. So how we will adjust this? 2a into sin t by 2 by cos t by 2 we will write and one more sin t by 2 we will write as it is. So sin by cos is tan 2a tan t by 2 sin t by 2. This is length of normal. Now next we need to find length of subnormal or subtangent, anything you can find first. So length of subtangent is mod y1 by m. What is y1? A into 1 minus cos t by tan t by 2. That is equal to mod A into 1 minus cos t is 2 sin square t by 2. By tan t by 2 is sin t by 2 by cos t by 2. Sin t by 2, sin t by 2 cancel. This cos t by 2 will go up. That will become 2a sin t by 2 cos t by 2. But we know that what is 2 sin t by 2 cos t by 2? That is sin t. So that is a sin t. This is length of subtangent. Now what is length of subnormal? Length of subnormal formula is mod y1 into m. That is mod a into 1 minus cos t into tan t by 2. That is equal to mod a into 1 minus cos t is 2 sin square t by 2. Tan t by 2 is tan t by 2 only. So that is mod 2a sin square t by 2 tan t by 2. Why I am not changing tan as sin by cos? Because it will not get cancelled. If it would have got cancelled, we would do it. Okay.